All right, so a dot plot is a way to show data on a number line using dots or X's. And I know I wrote that fast. That's because I'm going to come around with a glue in. So that gives you some time to finish writing that. All right, this glue in just either on the left or the right side, depending on how you prefer your notes. We're going to help you with this one. Hey guys, look at these ones. No? Alright, as we work today, we are going to use some colored pencils. So if you want to grab out those colored pencils, eventually we'll use 5 colors. So if you want to grab out 5 colors, you can. We'll just start with 3 though. Nothing too crazy. We're going to go through this first dot plot a little bit faster. Dot plots are pretty self-explanatory. At this point, most of you can probably figure it out. If you can't, then we'll do a short explanation. Alright, so go ahead and get that glued in on the left or the right side. Teamwork. Alright, so on this first one, we're going to find some information about it. First thing is, what is this first dot plot describing? What do these numbers represent? Roy, what do these numbers represent? You can't read.
No, I don't have my glasses.
They're literally on your head, bro.
They aren't mine.
Oh, you don't have your own glasses? Okay. Well, thank you for being brave and admitting that you aren't able to today. That's okay. Ruben, what's this about?
Minutes to run.
Yeah, minutes to run a 5K. Good. We have a title. Amazing. That tells us what our data is about. How are we measuring our numbers? What does the 40 really represent? 40 inches, 40 feet, 40 seconds, 40 years. Minutes! See, these are questions my last class didn't answer. It was terrible. You guys are crushing it. Okay, so this right here, this is our data listed as numbers. Might need to sharpen my pencil too. Okay, this is our data listed. As you look at our data, is our data listed least to greatest? And these numbers? No, it goes 40, 31, 30, 25. It's kind of all over the place. So putting it on a dot plot is kind of nice. It's an easy, quick way to look over things because now it's listed least to greatest. Okay, what are we counting by on our number line? It looks like it's counting by 2s. They labeled every other. But what does each tick mark actually represent? 1. So it really goes like 25, 26, and then this is really 27, 28. They just skipped every other one to make it look a little bit better. So kind of by 2s, kind of by 1s. Depends on how you look at it. Okay, we're just going to find 2 things with this. We're going to find our range, and we're going to find our mode. So to find range, what 2 numbers do we need to find first? Good, our minimum and our maximum. What is our maximum? 40. Good. And that's our maximum. minus, what's our minimum? Good, 25. So 40 minus 25. Who's my human calculator today? You say 35? Not 25. 15, yeah. 40 minus 20 is 20, and then we have to subtract 5 more, so it should be 15. Okay, our mode is what happens the most. And that, again, should be really easy to tell. Okay, our mode should be those numbers that have the most dots. So which one have the most dots? Good, 32 and 38. They both have 2 dots. We have 2 modes here. And that's all we're going to do with that first one. Okay, a dot plot is really nice if it's numbers that fit well onto a number line, if we can count by 1s or 2s. Once we start having to count by like 50s or 60s, we have to start rounding numbers, and so it depends on if it's good numbers to round or not good numbers to round. This data set is really easy to use a number line with because our lowest is 25 and our highest is 40. They were able to count by 1s even. If I was doing it, I would have counted by 2s. Okay, but overall, these numbers are still rounded. When we look at these numbers, do you think all these people finished at 30 minutes exactly, 25 minutes exactly, 38 minutes exactly? No, they probably have like some sort of seconds added on, so maybe 38 minutes and 15 seconds. Or even this 32 might have been 31 seconds and 50 seconds. 31 minutes and 50 seconds. Would have rounded up to 32. So again, not super great if we need to know exact numbers in this case, but if we just need an overall general idea of how long did it take people to run a 5K, it gives us a general idea. Okay, most people kind of are in the middle range here between 30 and 38. Our fastest time was 25, and our slowest time was 40. Okay, next up we have hits in a round of hacky sack. Okay, I don't know why I keep using this example. Hacky sack is a game that used to be popular back in the 2000s and the 90s where you take like a ball and it's kind of filled with like beans. It's like a scrunchy ball kind of, but it's like, okay, and you like throw it up, and then when you throw it up you like hit it with your foot, and you try and hit it and keep it off the ground. And you hit it together. I don't know. I used to play it in between classes. I was pretty cool back in the day. Just kidding. All right, so we're going to do a number line here. We're going to create our dot plot. First thing we need to do is decide what should we count by on our number line. So what is my slowest hits? Or fewest hits? 3 is my minimum. What's my maximum? 12. So if I need to count from 3 to 12, should we count by 1s, 2s, 10s, 100s? Probably just by 1s. 3 and 12 aren't even 10 apart, so it shouldn't take us too much space. So I'm going to start at 3, and I'm going to count up to 12. When you do your number line, try and keep them spaced out evenly. And then remember your numbers are for the tick marks, not the spaces between. So it should be a tick mark, and right underneath that tick mark should be a number. And we are going up to 12. I made mine way too big. Well, not way big, just a little bit big. I got an extra number on there. I got 13 because I just wanted to use that space up. Okay, and then either we can use dots or we could use X's, or if we wanted to, if it's a round of hacky sack, if we were doing this on a computer, we could even find a little ball that looks like a hacky sack and put that on there. Really, what a hacky sack, it's kind of like if you were playing with a soccer ball and you're trying to keep the soccer ball from hitting the ground and you stand in a circle and you just hit it from each other. Or a volleyball, when you pass the volleyball around and see how many times can you hit it in a circle without it touching the ground. It's really what it is. All right, cool. Okay, then what's really nice is as we do this, we don't need this in order. Once we have these numbers, we can go in any order we want. So the first one we have is 11. So with 11, I'm going to put a circle above it. Okay, if you wanted to do an X, you could do an X. But we want this first row to kind of be the same height. We don't want it to look like something has more than another. So as I do 9 here, I want 9 to line up with that dot. Okay, I don't want one to be above the other. They both have 1, so I want it to look equal. Does that make sense? Try to make your dots about the same size. Okay, then we have a 6. Again, we're still on the just 1 dot each. So again, we want those to all kind of be equal. 12. But here we have 6. So now that we have another 6, we're going to stack it. So above the 6 is another dot. Another 6. So we actually have 3 6s, so 3 dots on 6. And we have another 12. So again with this 12, when I put this circle, I want it to be matching about the second circle here with the 6. I want the 2 to match the 2. It shouldn't look like this 12 has more than this 6. It should look kind of even. Okay, and then we have 3 and 4. Okay, if you want to double check, you should have 1, 2, 3, 4, 5, 6, 7, 8, 9 dots. 6, 7, 8, 9. And then you know you did it right. All right, that is all we're doing for dot plots to start with today. Pretty straightforward. Feeling good about it? Makes sense? Super hard? Super hard. I know. Makes me want to cry every night. Just kidding. All right, next up we got stem and leaf plots. We're going to do our definition here kind of with a big example. And then we have a glue in, and the glue in's going to go on the next page because these take up a little bit more space. Okay, so next we have stem and leaf plots. When you think of the words stem and leaf, what do you think of? A leaf? Good. Or plant. Good, because plants have stems and leaves, specifically like flowers, right? So if I draw a flower, here's our beautiful dandelion that's going to blossom soon, now that it rained a bunch today. I'm sure we'll have lots and lots of dandelions. Okay, which part is the stem? Yeah, that line is the stem. Now when I draw leaves, do leaves come out of the flower or do leaves come out of the stem? Leaves come out of the stem. So as I draw a leaf here, very fancy leaf, the leaf is connected to the stem. If I was going to draw another leaf, does that leaf come out of that leaf? Is it connected to the leaf or does it go back to the stem? Yep, it goes back to the stem. If I draw a leaf on the other side, it's connected to the stem. Okay, as we draw leaves, leaves are always connected to this stem, and that's why we call it a stem and leaf plot, is because each leaf is separate, but each leaf is connected to the stem. Okay, if that picture, if drawing's not your thing, that's fine. It was just kind of a visual of why we call it a stem and leaf plot. So for a stem and leaf plot, it's actually a table. We have a stem, and then we have a side that's labeled leaf. One of the most important parts of a stem and leaf plot is the key. Key is really important. The key is going to tell us how to read the stem and leaf plot. Similar to like when you look at a map, sometimes a key can tell you like which cities are capitals or where the libraries are located or the police stations. There's little symbols on the map or the star that says you are here. Okay. So our definition, we kind of have two things that's important about this that we're going to write, and then we do have a glue-in that we'll do on the next page. Okay, is first off, it's a way to show data using place values. When we talk about place values, that means we're breaking up numbers into their digits and what position their digit is in. So we have like the ones, the tens, hundreds, thousands, right? And then even past the decimal place point in the other way, we have like tenths, hundredths. Okay? And then what's really important is that each individual leaf is connected to its stem number. So all the leaves are connected to the stem. All right, once you get that written, we do have a glue in. It's going to go on the next page because it is a little bit bigger. We are going to draw a stem and leaf plot and create one. So I highly recommend moving to the next page. I know some of you like to try and get everything squished onto one. I'd recommend getting this one to be a little bit more spread out. Okay, and you guys figured out that stem and leaf plot in the beginning pretty quick. Okay, it was nice that we had the list of numbers so we could see what belonged with what.
Okay, this is more complicated, but you might want to write down, okay? I know you're not feeling super good. Try your best.
All right, so go ahead and get that glued in on the next page. Hopefully I have this all written down. I don't see anyone still writing. I see one person still writing. I lied because they were on their phone when we were writing. All right, so on this one we have 3 examples that we're going to work through. The first example, we're just going to work on reading it. The second example, we're going to find some numbers. And then the third example, we're actually creating a stem and leaf plot. Okay, so as we take a look at the first one, look at yours. I'm gluing mine in. As you take a look at your first one, what is it about? Test scores. Good. Does it tell us how we're measuring test scores? Are we measuring in percent or points or, I don't know, smiley faces? Doesn't tell us. Hopefully we're measuring in points. Otherwise, only one person passed the test with the 60%, right? Everyone else failed. Yikes. Okay, so hopefully it's like 60 points and maybe it was out of 60 points or 65 points. That's what I'm hoping for. I don't know. Otherwise, this class has to all retake their test. Yikes. All right, so as we take a look at this first example, again, the idea is that you can match these numbers with the numbers in the stem and leaf plot. It's kind of nice. Our numbers here are least to greatest, so we should be able to note right away 31 is like 3, 1. 34 is 3, 4. So each of these leaves, each number in the leaf is separate. Notice that there's no commas telling us that they're separate. Big thing about stem and leaf plots is our leaves can only have one digit. Okay, we can't have like 610 and then write 10 over here. It has to be just one number, one number. Okay, big idea here is that we do have this key. The key tells us that 39 represents 39. So that key tells us that the stem is what place value? The ones, tens, hundreds, or thousands. The 3 is the 30, which is in the tens place. You guys were doing so good here. So this is the tens, and then what place's value is this one? The ones. The ones place value. So for example, like 49 gets broken up into 40 and 9. So we're doing like how many tens are there and how many ones. In 49, there's 4 tens and 9 ones. So 49, if I wanted to color code where that is in the table, that would be the 4 for the 40. and that's connected to the 9, this leaf. So it looks like there's a lot with these 50s, but really with those 50s, that 5, 2 represents 52, and then 53, and then a 5, 5 represents 55, but there's another 5, so there's another 55. So this is really representing 4 numbers in that leaf. Okay, again, we don't put commas in a stem and leaf plot because each number represents its own leaf. It's automatically assumed that each number is its own leaf. All right, getting humid in here. All right, we got 2 more. Okay, and this one we're talking about the boiling point. So what are some things that boil? Water, liquids, right? I think this might actually be elements, when elements start boiling. I don't know. I might be wrong. Who knows? Don't really know. So hopefully this would be like in a science textbook to show you a boiling points without having to list it. It doesn't tell me which one is which liquid, so it's not super helpful in that aspect. But what's nice is it really boils down those numbers. It takes those numbers and simplifies them into easier numbers so it doesn't take up a lot of space. Okay, that's really the biggest thing with a stem and leaf plot, is it saves space. Okay. All right, so as I take a look at my stem and leaf plot here, it tells me my key, 1, 5, represents 1,500. So what does my stem represent and what does my leaf represent? Which place values? In the leaf part, this 5 represented 500. So the leaves are actually the hundreds place. And what's the stem actually? The thousands. Okay, so we're breaking up numbers into thousands and hundreds. Now, if there was a number like 1,542, it would just be classified as 1,500. Okay, so they had to round some of these probably. But again, it saves space. It's nice if you're collecting data and not to have to write down all these really big numbers. All right, so to start off with, let's find our maximum. Which number is going to be our maximum number? When I look, maximums you might think is the highest number. So you might be thinking that this 9 is the highest. 9 is not the highest, because that 9 really represents what? 900. So I want to find first what's my highest thousand, because thousands are bigger than hundreds. 4. So 4,000, and that goes with 100. So 4, 1 is my maximum, because 4 is my biggest thousand. So 4, 1, which represents 4,100. So we really have to make sure that we really think about these numbers connected to their thousands. Even though 1 is not the biggest leaf, we have leaves that are 9. 1 is the biggest because it's connected to the 4. And the 4 is the biggest thousand. All right, what about for our mode? When we look at a mode, again, we're looking for most. But we need a number that happens the most in the same thousands. Okay, these 9s down here can't be combined with this 9 up here. Because this 9 up here just represents 0,000, so just 900. These 9s represent 2,900. It's not a repeat. So we're looking for the most that repeat, but it has to be in the same row. So which ones repeat the most within the same row? hopefully you're seeing these ones. Okay, these ones repeat a lot. There's 4 of these ones in the same row. So the mode has to be together combined. So these ones in this row, there's 0 thousands. It's just 1, so those represent 100. All right, last one we're doing with this one is the median. For some reason, people like to do median with this one. I think it's crazy. I don't like doing it. Okay, if I was doing this in my quick check, I would actually take out a whiteboard and rewrite these numbers because, I don't know, my brain does not work this way in this table. But for some people, they really like it. I don't know. You do you, bro. All right, so we're going to start off with doing our median. Remember, that's our high and low when we're finding the middle points. So I'm going to use dots. Okay, so our lowest is actually this 1, because that's our 100. And remember, our highest is really 4,100. So when you do the dots, we're dotting the leaves, and we're going to find what's the middle leaf. Okay, my next lowest on the leaf here is this 1, again. Okay, there's no 3,000s. That's left blank. So my next highest is 2,900. I'm actually starting at the 9 here, and then I'm going to work my way in. So as we would do the minimum and work our way out, we're going outwards to the bigger numbers. As we work maximum down, we're working our way in. So 9 and 1 go together. Then I have another 1 and another 9, 2,900. Okay, then I have 100 with 2,600. So far I have 4 below and 4 above. You should be able to count those dots. Then I have a 300 goes with the 2,400. Then a 300 goes with 2,200. Then 400, is that going to go with the 5 or the 8? Which one's bigger? Yeah, the 8, 1,800. So I'm at the point where I have 1, 2, 3, 4, 5, 6, 7 below, and 1, 2, 3, 4, 5, 6, 7 above. So I have 2 numbers in the middle. In the middle I have this 9 and this 5. So what do I need to do when there's 2 numbers in the middle? Add and divide by 2. But I can't just do 9 plus 5 divided by 2. That's not what we're finding. Okay, what do these numbers actually represent? What does the 9 actually represent? 900 plus, what does this 5 represent? Not just 500. 1,500 divided by 2. Okay, 2 ways to do that. If you're using Desmos, you can put in that fraction right away with input 2 on the bottom, or you can do it in 2 steps. I know a lot of people did that. So just 900 plus 1,500, or 1,500. We hit equals, and then we do divide by 2. And our answer is 1,200. When you put answers into Schoology, we aren't going to use commas, just the number 1200. All right, you guys are doing way better than my last class. I know it's getting a little warm in here. That's what happens when it rains. We do have, why are you closing? We have one more. One more, yeah, we got to do an example now. We got to create one. All right, and last one, we're doing annual precipitation. So we're going to create a stem and leaf plot. So off to the side here, we're going to make our table with stem is always on the left and leaf is always on the right. So what we need to do is we need to figure out how to break these numbers up into 2 parts. All right, so as we break up these numbers into 2 parts, we're going to take a look at these numbers. We could break it up into the number and then the decimal. So we could break this up 54.4. We could put 54 over here and then the 4 over here for 54.4. Okay, but when we look at this, we still want to consider what's the lowest, where we're going to have to start, and the highest, what's the highest we have to go to. So what is my least? What's the fewest inches? What's the minimum? 9.8. Good. Seeing a couple people on our phones. We're getting distracted. And it's not just these two goofs back here. All right, so we have 9 as our lowest. What's our highest? Close. It's actually a 68. So if I counted by ones or by wholes, I'd have to start at 9 and then count all the way up to 68. I'd have to go 9, 10, 11, 12, 13, 14, 15, 16, 17, all the way up to 68. Is that going to be doable? No, the whole point of a stem, it's doable. Is it going to be efficient? No. Okay, the point of a stem and leaf plot is to condense our work, make it easier to work with. So we're going to just want to do tens and ones. But to just do tens and ones, we're going to need to round, so all of these are just whole numbers. So first thing I'm going to do, I'm going to zoom in here so you can see 54.4. What would that round to? 54 or 55? 54. So we're going to get rid of those decimals so that 54, I can break it up into a 5 and a 4. Okay, 18.4, 18 or 19? 18. 39.4. 42 is just 42. 31.2. 31. 57.8. 68, 33, 10, those are all good. We're at 9.8. We'd round up to 10. 57.2. 57, good. 46.6. 42.8. 52.4. Good. 59.2. 59 and 50.6. 51, good. I was going to go with 50, so I'm glad you said that. My brain stopped working there. All right, so our stems are going to be the tens place. Do I need a tens place of 0 now? Is there any ones that don't have a 10? No, our lowest now is 10. So I'm going to start at 1. Now, stems can't skip numbers. So I'm going to start at 1, and I have to go all the way up to my highest 68. So I'm going to go 1. There's my 20s, 30s, 40s, 50s, and 60s. So I have to go all the way up to 60s. Good morning, Ayan. All right, so as I take a look, we're going to start with the ones. The big thing with stem and leaf plot is we do have to go in order least to greatest. So as I take a look at my ones, I'm going to color code this. You do not have to. It's up to you. Okay, as I look, I have an 18 that starts with a 1 in the tens place. And my other ones I have is just a 10 and a 10. So those are the 3 numbers I need to list next to this 1. And I want to go least to greatest. So what is my smallest number that has a 1 in the tens place? Yeah, 10. So I'm going to put a 0 there for 10. I have another 10, so another 0. And then an 18, so an 8. So that really represents 3 numbers, 10, 10, 18. Okay, if you want to try and work ahead, you got it. Do we have any 20s? No, so I'm going to skip that one. I'm not even going to give it a color because that's a waste of colors. So I'm going to 30s next. Again, I'm color coding. That way it's a little bit easier for me to read and see how we did our work. So I have 39, 31, a 33. I think that's it. So I want to start with my least 30. So what's my smallest 30 I have? 31. I was going to go 33 too. And then 33. And then 39. Okay, next we have our 40s. This one is 3 again. We have a 47, a 43, and a 42. So 2, 3, and 7. 42, 43, 47. All right, the 5s is the one with a lot. So that one's going to have to take a little bit more brain power thinking how to organize it. Well, I got a color code first, girl. Chill. I like color coding. Makes math a little less boring. Not a lot less boring, but a little bit. All right, so it might be helpful to think through the numbers. So my smallest 50 would be 50. Do I have any 50s? Nope. 51s? Yep. Any other 51s? Nope. 52? 53? Nope. 54? 55? 56? 57? 58? And 59. So that's another way to kind of do it rather than looking and just ordering them least to greatest, is you can kind of just check through those numbers yourself. Up to you. Everyone's brains works a little bit different. All right, and then our last one is 60s. Do we have any 60s? Yeah, we have a 60. What? 68. Don't close your book yet, though, because we have the most important step next. What do we need on our table for our reader? A key. We have to tell our reader, how did we make these numbers? My favorite way to make a key is to pick one of the numbers that we did. Fatuma, since you helped us so much, which number is your favorite number of these numbers? Yeah, you. Just pick a number. Okay, 43. Whoa, that's the same number we picked last year. That's crazy. Okay, so 43 in our table was represented by a 4. And then we did that line for the table. And then 3. Make that line really obvious so it doesn't look like a 1. So when we separated 4, 3 out, that 4, 3 really represented 43. And that tells our reader that we have 10s and 1s.